So let's start with volumetric efficiency. Okay, volumetric, we have to understand what is volumetric efficiency, and before that you all should know why the volumetric how the volumetric efficiency is created, and how it will be calculated. Okay, and the points are here. The actual volume sucked into the cylinder during the suction stroke is always less than the swept volume. Okay, in the PV diagram I have shown you the one is effective swept volume and another is piston displacement volume. That actual volume which is sucked into the cylinder, that means that is the effective swept volume, is definitely less than the the swept volume, that is piston displacement volume. There are several reasons, but another one reason is that it is due to the resistance offered by the inlet valve to incoming air. Yes, it happens when the air is entering into the cylinder, through the inlet valve, the resistance is sometimes provided by the inlet valve. That's why the amount of air which should actually the air should enter into the cylinder, that might not enter into the cylinder. That's why that amount is reduced. Clear? And another point is temperature of incoming air. Okay, the cylinder is hot. Okay, the temperature of cylinder is normally higher. Okay, when air is entering into the cylinder, the volume, specific volume of air increases, and that reduces the effective stroke volume, And also another point is back pressure of residual gas left in the cylinder clearance volume. This point I told you in the previously I told you in the derivation. The clearance volume which has been remained in the top of the cylinder head, that expands during the next cycle. So that back pressure reduces the effective stroke volume value. That's why when the amount of air entering into the cylinder is always less than the theoretical value, that is the piston displacement volume. Okay, and what is the volumetric efficiency? It is defined as the ratio of actual volume air sucked into the compressor measured at atmospheric pressure and temperature to the piston displacement volume. Okay, piston displacement volume is the swept volume, that is the volume created by the piston when it is moving or reciprocating from TDC to BDC. And what is the actual volume? Actual volume is the V1 minus V4 in the previous graph. This is the effective swept volume, that means this is the actual volume, and this is the piston displacement volume, that is the V1 minus V3, and the actual volume is V1 minus V4. That's why the ratio of actual volume to the piston displacement volume is called as volumetric efficiency. And how you will derive the formula for volumetric efficiency, I am showing you. Volumetric efficiency is actual volume divided by piston displacement volume. Okay, and if I will draw the graph like this. This amount of volume is called as clearance volume, P and V, and this is the effective swept volume, that is V1 minus V4, and this is the piston displacement volume, that is V1 minus V3. Clear? And this value divided by this value is the volumetric efficiency. Okay, that means actual volume you can write V1 minus V4 divided by piston displacement volume, that you can write, or it is swept volume, you can write V1 minus V3. Clear? And V1, what is V1 value? V1 is the total volume V1 is the total volume, and total volume is what? Vc plus Vs. And what is Vc plus Vs? Vc means clearance volume, Vs means swept volume. Clear? And this value is the total volume up to this point. Up to one point is the total volume. That is the total volume is the summation of clearance volume and the swept volume. Okay? And V1 is equal to Vc plus Vs. Okay? And in here, in the derivation of volumetric efficiency, you can write in the place of V1 Vc plus Vs minus V4 divided by V1 Vc plus Vs minus V3. Clear? Okay. So, Vc plus Vs minus V4 divided by Vc plus Vs, here V3 is there, V3, what is V3? V3 is the Vc value, okay, because this is the 3 point, this is the 3 point. So, V3 is equal to Vc, okay. So, the place of V3 you can write Vc. So, Vc will be cancelled out, you can write Vc plus Vs minus V4 divided by Vs. Okay. So, this is the what? Volumetric efficiency. Again, we can simplify this formula. Volumetric efficiency is equal to Vc plus Vs minus V4 divided by Vs. Okay. So, here you can write individually Vc by Vs plus Vs by Vs minus V4 by Vs. Okay. So, Vs by Vs cancel out, 1 plus Vc by Vs minus V4 by Vs. Okay. So, here you have to do something to simplify this formula. 1 plus Vc by Vs minus V4 by Vs, you have to multiply 1 Vc and you have to divide 1 Vc. Clear? So, again you can write 1 plus Vc divided by Vs minus, you can simplify Vc divided by Vs whole into V4 divided by Vc. You might have understood this derivation. What I did, first of all, this is Vc plus Vs minus V4 divided by Vs. Okay, it has been derived, and individually we will divide Vc by Vs plus Vs by Vs minus V4 by Vs. Okay, so again Vs by Vs cancelled out, 1 plus Vc by Vs minus V4 by Vs. Okay. In the next step, what we will do, 1 plus Vc by Vs minus V4 by Vs into Vc by Vc. Okay. Here to simplify the formula, I am multiplying 1 Vc and also I am dividing 1 Vc. Okay. This will be cancelled out 1, but this will be used in the next step. Okay. 1 plus Vc by Vs minus, I have separated this Vc by Vs into V4 by Vc. Clear? Up to this step you must have understood. Then in the next step, that is equal to 1 plus, so here you can take Vc by Vs is equal to C. Okay, one symbol is C, that is equal to Vc divided by Vs. So, you can simplify the volumetric efficiency formula, 1 plus C minus, in the place of Vc by Vs I have mentioned C, minus here also Vc by Vs is there, C into V4 divided by Vc. Clear? Clear? Up to this point you must have understood. So in the next step, I am erasing it. In the next step, that is equal to 1 plus C minus C into V4 divided by V3. And what is V3? V3 is the clearance volume. V4 is Vc is equal to V3. V3 is the clearance volume. So, you can write 1 plus C minus C into, what is V4 by V3? 3 to 4 process is what? Which process? That is expansion process. 3 to 4 process is the expansion process having the law of Pb to the power Ne is equal to constant, having the index Ne. Here the index is Ne. Okay, index of expansion. So during this expansion process, it follows, this is polytropic expansion process, it follows the law of Pb to the power Ne is equal to constant. So you can write P3 divided by P4, that is equal to V4 divided by V3 to the power Ne. Okay, because Pb to the power Ne is equal to constant. From this you can derive this. Okay, because 3 to 4 process is from the 3 to 4. So when the formula is this, law is this, you can derive the formula P3 by P4 is equal to V4 by V3 to the power Ne. So I can write V4 by V3 is equal to P3 divided by P4 to the power 1 by Ne. I can write V4 by V3 is equal to P3 by P4 to the power 1 by E. So in the place of V4 by V3, I can write P3 by P4 to the power 1 by Ne. This is the formula of volumetric efficiency. 1 plus C minus C into P3 by P4 to the power 1 by Ne. Again we will simplify. This formula. P3 is what? P3 is equal to P2. You all know this is the constant pressure process. P3 is equal to P2. And P4 is what? P4 is equal to P1. This is also constant pressure process. P4 is equal to P1. So, in the place of 1 plus C minus C into P3, in the place of P3 you can write P2, in the place of P4 you can write P1 whole to the power 1 by Ne. Clear? This is also volumetric efficiency. Also you can use this formula. Clear? Again you if you want to simplify the formula, you all know this is the compression process. This process also follows the law Pb to the power Nc is equal to constant. Okay, this compression process 1 to 2 process, that process also follows which law? Pb to the power Nc is equal to constant. I am erasing it. Okay. So for the process Pb to the power 1 to 2, for the process 1 to 2, Pb to the power Nc is equal to constant. That means you can write P2 by P1, that is equal to B1 by B2 to the power N. Okay. So V1 by V2, that is equal to P2 to the power P1 to the power 1 by Nc. This is Nc. P2 by P1, if we are considering 1 to 2 process, so P2 by P1 is equal to B1 by B2 to the power Nc. So B1 by B2 is equal to P2 by P1 to the power 1 by Nc. Clear? This is from the compression process. Okay. So here in this final derivation, what was the formula? 1 plus C minus C into P2 by P1 to the power 1 by Ne. Okay. So now let's assume Nc is equal to Ne is equal to N. If this index will be same, both the indexes will be same, Nc is equal to Ne is equal to N, then you can write this will be same, P2 by P1 to the power 1 by Ne, you can write here only N. Clear? So here you can write volumetric efficiency is equal to 1 plus C minus C into V1 divided by V2, because V1 by V2 is equal to P2 by P1 to the power 1 by NC. Okay. If the index x will be same for the compression and expansion process, the formula of volumetric efficiency can be 1 plus C minus C into V1 divided by V2. What is V1? V1 is the total volume and V2 is the after compression volume. Okay. So, this is another formula. You can also use this formula for the problem solving purpose. Okay. So, here you just have to remember the C. C is the BC divided by Vs. You can easily derive the formula of volumetric efficiency. You have to start from the formula, that is the ratio of actual volume to the piston displacement volume. Okay. Actual volume is the V1 minus V4 and the swept volume is V1 minus V3. Okay. This ratio of actual and swept volume is the volumetric efficiency. You can easily derive. So, what is the C? Vc by Vs, and Vc is what? Vc is the clearance volume. Okay. That means this C symbol mentions or indicates it is the ratio of clearance volume and the swept volume. Clearance volume and the swept volume, and swept volume is what? V1 minus V3, and clearance volume is what? V3. Okay. The ratio of Vc by Vs, Vc and Vs is C, and the final formula for volumetric efficiency is 1 plus C minus C into V1 minus V2, or 1 plus C minus C into P2 by P1 to the power 1 by Ne. Okay. Or if the index will be same, 1 plus C minus C into P2 by P1 or P3 by P4 to the power Ne, or P2 by P1 to the power N1 by Nc. Okay. This is the final formula for volumetric efficiency. So, you must have understood all this derivation of work done for the single acting air compressor with clearance volume, and also you will able to understand the volumetric efficiency derivation after this video. So, definitely in the next class we will continue with free air delivery and multi-staging compression. We will derive the expression of work done for two-stage air compressor, and we will solve one problem. So, thank you all for this class. Goodbye.